All right, folks, we should be live and everybody can hear me. We should actually have music today too. It definitely helps cut out some of the AC noise because I live in the place where the air hurts my face for 4 months of the year and then it just gets way too hot after that. So, looks like I am live now. Say hello in chat when you are ready. Alright, I actually have an agenda and notes instead of just a vague idea of what I'm doing today. So we're in uncharted territory where I'm actually planning stuff in advance and whatnot. Because today we are going to expand some storage. We're going to start expanding some storage in my home server today. And hi Shelby, welcome to the stream. We're going to expand some storage today in Zeek, my hypervisor. So right now I have 3 storage pools on my server. One of them is, this is a really bad joke because they're all running BTRFS. We have an NVMe pool called /butter, and then we have margarine for the SSDs, and then Crisco for the hard drives. The margarine pool is made up of really old SSDs that I've kind of hodgepodged over time. You can actually see that they have differing sizes and whatnot. So they're getting old. NVMe is super cheap now because of the simpler design. It's faster and cheaper because it's just a little gum stick. They don't have to put a plastic case and make the separate SATA and power connectors. They just have to make the PCI fingers and the little PCB board that's the little gum stick. So that's really nice that you can get something faster, cheaper. They have little 50, I shouldn't say little. If your motherboard supports a feature called PCIe bifurcation, you can take a 16x slot and then divvy it out into 4x4 lane setups. So you can take one UPCI card that costs $50, pop it in either a high-end desktop or a server motherboard, and then it'll break out that 16x slot into 4 slots. So that's what I did a couple days ago, but I wanted to wait till I could stream and show you guys some of the cool stuff you can do with BTRFS before I did it. So what we are going to be doing today is sudo BTRFS file system show. So this is a better representation of it. So here's the margarine pool. You can see it's made up of differing drives from differing eras. It's half full. All the drives are super old. And then we have this lovely pool here that it would be getting kind of full if I added it in. Plus I wanted to make sure I have enough IOPS available. I probably do, but it's home lab, so overkill is fun. And then we have the big chungus pool here, which we mostly just use for Nextcloud data and video camera storage. The reason why I'm okay putting some data on these old, really slow devices is even though they have low throughput and low IOPS, it's still the case that spinning Rust drives gets cheaper for larger storage pools. So it's okay to put things that don't require a lot of IOPS. So for data that's being read and written to over a network connection, like a video camera stream, or a couple of video camera streams, or Nextcloud files where they're interacting with the network more than they are an application inside of the same computer, the network latency is usually going to be the constraint, not the the network access is going to be the thing that's taking up all the time, not seek times and other disk issues. So if you separate data correctly, you can still use hard drives in a few places, and it's perfectly fine. Putting your Postgres database on here is a terrible idea, though. So what we want to do is we want to add 2 hard drives to this pool, but once we're at 4 hard drives instead of 2, we can switch it from a RAID 10 array to or from a RAID 1 array to a RAID 10 array, which BTRFS doesn't mean what you think it does. So In a RAID 1, traditionally that means a mirror. So you have a mirror, which is two devices writing the same data to them multiple times. In BTRFS, that means the data will get written to the file system twice. The reason why that sounds different is when you start adding three or more devices. So if you have four devices in a BTRFS RAID 1, then that means the data will be written to any two of them. You can lose one disk and still be safe, and then once you lose the second disk, you suffer data loss. RAID 10 is the same like resiliency guarantee, but it can read and write to the more of the drives at the same time. And then parity RAID, so RAID 5 and RAID 6 with BTRFS, there's issues with, so you should just avoid it. But again, because the RAID, it's not that big of a deal that parity RAID's busted, because you can still use like RAID 1. You can still use like a RAID 1 with 3 or 4 devices, and then they have something called RAID 1C3 and RAID 1C4, which give you kind of the features of like a RAID 6 or a RAID 7, where the device is written to multiple drives to reduce failure. A RAID C3 means 3 copies are written to the array, 3 copies are written to the array, not 2. And as a result, you can lose up to 2 drives and not suffer data loss. C4, same feature as RAID C7, you can lose 3 to block devices, and you're fine. So you don't necessarily need parity, and I'll get into why I'm using BTRFS instead of ZFS in a little bit. So we have 2 disks, this guy right here, and this guy right here, just so we can get a better view of them. We're going to do sudo ls blk, then we're going to grep that for, so those are the block devices we want to add our 2 new drives. So we're going to do sudo BTRFS device add /dev/nvme 1m1, and then /dev/nvme 3n1. So those are the 2 block devices we're going to be adding. And then while we're adding those devices, we're going to do a deconvert, we're going to do a deconvert, which is saying, hey, change the data resiliency to a RAID 10. And then we're going to do an mconvert to RAID 10. Mconvert means metadata converting, so BTRFS, you can do something interesting where metadata has a different resiliency than data, so you can make metadata more resilient than data, or you can just be lazy and do metadata is also RAID 10. So, and then we're going to put those in the butter pool. And poop. That we did not get happy output. Oh, okay. I got a little greedy there. So first we have to add the devices. Mount butter. Oh my god. I can't spell device apparently. Device add. There needs to be like, I don't drink, so we can't do like a drinking game. I need to do some sort of game where like I have to do something every time I misspell something. I could do push-ups or like some sort of exercise. That's what I do for kids jiu-jitsu, because I suck at remembering names, so I'll like, if I screw up a kid's name, I'll be like, I'm sorry, and then do 5 push-ups, so that way I'm like negatively reinforcing I need to learn this kid's name. Alright, so while those devices are being added, let's talk about why I use ButterFS instead of ZFS. So I actually have some points written up here. So the alternative to ButterFS is ZFS, and ZFS is better. It has more features. The one thing that actually I don't like about ZFS is you have to be very, there's working on this, but you have to be very careful about where you're, or you actually have to like plan out your disk topologies ahead of time, because you have to grow by VDEV. So you can't just like mishmash disks together like you can with ButterFS, but parity RAID actually works. So if you have like a pool of 8 drives, you can use a RAID Z2, which functions like a RAID or a RAID 6, or RAID Z1 for a RAID 5 if you have like 4 disks. It follows like more of those traditional storage things. Mounting makes more sense. So the way ButterFS works, cat etsy fs tab, is I'm mounting a block device at boot, and I'm not mounting or I'm saying, hey, mount this physical device. I'm not mounting virtual devices, which is really interesting, because if you use like MD RAID or ZFS, you get a virtual device that you mount into the file system. So if a disk fails, the array can mount in a degraded state and it's fine. ZFS send receive, there's way more tooling and documentation for. So ZFS, it does have its benefits over ButterFS, but one issue is if you're an Ubuntu user, or if you don't like Ubuntu like I do because of snaps, if due to the performance implications and the fact that like they encourage you to use a centralized proprietary backend. Canonical also just kind of took over the LXD project, so I am not a huge fan of the direction Canonical's taking Ubuntu, and that's usually the easiest. Either using Ubuntu or some sort of appliance distribution is the best way to get access to ZFS on Linux, and I don't want an appliance distribution. There's nothing wrong with using something like Proxmox or TrueNAS Scale. It's just not what I want, because I want to specifically have certain things available like Podman and the Cockpit Machines interface, and I'm experienced enough that I don't need my handheld like those appliances do for a single node deployment. I couldn't do clustering by myself, but a single node deployment in my basement, I can handle all that. Okay. So I like to do my own stuff, and I like to use and I like Fedora more than Ubuntu. We'll get more into that later, but essentially my hate for Ubuntu in this use case kind of outstrips my need for ZFS. Because I've read the documentation on ButterFS, and have a good, decent enough understanding of how to like work around the pitfalls, like learning what the different RAID types are and stuff like that. I don't necessarily need ZFS, and while we're doing the balance, ButterFS balance start, I'll go into some of the things that I like more about Fedora than Ubuntu. Sudo ButterFS balance start deconvert equals RAID 10. Then mconvert equals RAID 10 / mount butter. Before we do that, sudo BTRFS file system show and. So as you can see now, the butter pool, it's only using 4 devices, but now we have these 4 devices in here. We have 4 drives. Now we can do a RAID 10. And that command is basically saying, hey, convert the array live so that it's using a RAID 10 topology instead of a RAID 1 topology, which is something super cool that you can do with ButterFS, is like take a RAID 1 to a RAID 10 or a single disk into a RAID 1. So the flexible topology is actually something that's better. The other issue is because I like Fedora more than Ubuntu, Um, Fedora, since they are legally registered in the US and they don't want to mess around and find out when it comes to will Oracle sue them for using ZFS, they don't bundle it in kernel, and the Fedora kernel updates frequently. Um, and so you have to build it in with DKMS, and I've heard horror stories about it. So I like having certain things about Fedora more than I like Ubuntu. I know how to deal with the pitfalls of ButterFS. I have backup tools. I have backup tools for ZFS or that don't require ZFS specifically, so I don't need ZFS. I can get all the stuff I like about Fedora and not use Ubuntu. So for those not in the know, ZFS was developed by Sun. Sun was bought up by Oracle, and I believe it was the Sun founder did not have very nice things to say or a positive opinion about. Did not have a very positive opinion about Linux and the GPL, so they created the CDDL or the Cuddle license, which is intentionally designed to not be compatible with Linux. And since I think this partially has to do with where Fedora is registered, and Red Hat in general and their strong relationship, so they believe that the CDDL is incompatible with the GPL, the Red Hat folks, the Fedora folks, so they avoid dealing with intellectual property issues. They're in the US, which has strict intellectual property laws, so they don't want to get sued by a notoriously litigious company. That's even been called, like, Oracle has been called a company that is a bunch of lawyers that occasionally release the software. So they don't want to mess around and find out. They're in a good venue for that. So they don't include all the kernel stuff. Fedora's kernel updates frequently, so you have to make sure that those kernel updates for Fedora are compatible with ZFS, and that's maintenance burden that I don't want to deal with. So ButterFS is good enough for my use case. The ButterFS is good for my use case, and there's a bunch of stuff I like about Fedora. One of them is how nicely Podman works. So I've tried using Podman with Ubuntu before, and it has some goofy networking stuff that's just worked out, and it just kind of works in Fedora, which is really nice. There's some other stuff too. Let's actually go into this. Is because I like Cockpit a lot. And because Cockpit is a Red Hat project, it's not that you can run Cockpit on Ubuntu. I believe you can run Cockpit machines on Ubuntu. But a lot of the networking stuff, because Cockpit is made by Red Hat uses FirewallD, and Ubuntu for their firewall abstraction uses UFW. You don't get all these helpful. The networking section isn't as helpful. They use SE Linux instead of AppArmor, and so Ubuntu hasn't made the contributions to make AppArmor work with Cockpit, and Red Hat, I'm guessing, like, Red Hat doesn't want to spend the time to make their stuff more useful for Canonical, which, fair enough. I have SE Linux turned off because I'm running containers in weird places, so don't hate too hard. It's something I should probably mess around with, but yeah. In a professional setting with stuff directly touching the internet, you should definitely be using SE Linux, and more than just Alert. So Cockpit works nicer. I get updates like right away. I'm running kernel 6.4, which is newer than what's in Ubuntu. And again, I don't like some of the technical decisions that Canonical has made, like the big push for snaps. What they did to LXD was kind of not okay, in my opinion. So yeah. Let's see how our balance is doing. It's still balancing. I believe I still have data. BTRFS. File system show. Guess we can go into what it balances. Balancing a RAID array is what happens sometimes is that writes will happen to like one side of the array more so than the other. And a balance is saying, hey, change or make it so the disks are equally being utilized. Because you could have situations like now where you've replaced or added disks that could change kind of like how the pool is laid out, and if you do a balance, it'll rearrange the pool with the current topology. Let's see, have I talked about everything here? Oh yeah, I get new shiny and it's stable. Podman networking gets goofy. BTRFS is good enough for my use case, and I don't have a ZFS dependent backup tool, so there are cool tools like Syncoid and Sanoid that are ZFS specific, but I wrote my own tool called Pengo Backup, which is just a shell script that will enumerate over all the virtual machines and their QCOW2 disks. So let's go through and migrate some data. So Cockpit Machines, really cool web interface for managing virtual machines on a single virtual host. It doesn't have the same like scale out abilities that something like Proxmox or even like vSphere does, but again, for my home lab it's fine. And I wanted to have something that I can manage OCI containers like Podman or Docker and virtual machines in one interface. So those are my VMs. Those are my containers. So I have one web GUI for managing both. It's super handy. So we can go into our storage pool here and start seeing what is going on Margarine. So we have some images. These guys can just get copied out. So let's open another connection into Zeek. Okay, so we're going to move mount margarine. I love how it's margarine. I think that's just cute. Mount margarine to we're going to move mount margarine based QCOW2 over to mount butter. Hopefully I can still actually write to those drives. It's like storage and networking stuff, there's always such a huge like pucker factor whenever you're doing it. Like I get freaked out every time I do storage stuff. And again, I have backups that I've tested, like all the virtual machine backups, I do that quarterly, because untested backups are no backups at all, or a better quip is they are Schrodinger's backup. You have backups that are both working and not working until you try a restore, and then they collapse into either the working or not working state. But yeah. So those two things are there. Fuzzy of the day, we need to stop. So fuzzy of the day, jellyfin. So Rhina old, I'm guessing can just get deleted. It's not in use. Again, this management interface is so helpful. You can manage things straight out of the command line, but it's a giant pain in the butt. So Rhina needs to be shut down. We'll just open up another cockpit tab. So we'll go to Rhina. We need to shut this down. The reason why we need to shut it down is that if we copy it while it's still active, the QCOW2 file is still like writing transactions, receiving telemetry data, in this case from all the access points that it's managing. Rhina's my TP-Link Omada controller, so we need to shut this guy down. So now that it's shut down, we can do a move command. I wonder if there's a built-in like move it between multiple pools. Nope. Okay. Well, that sucks. So we're going to move Rhina to butter. You're going to ask it very nicely to move it to butter. Also, there is a theme to all my storage pools, which is naming them after like a butter or butter derivative product. But there's also a theme to the host names as well. If you can figure that out, put it in chat. So while that copy's going, we need to change where this disk lives. So from here we can remove it. You can remove and delete the file. In this case, that's not what we want to do. We just want to remove it, which you can think about as detaching or just detaching it from the virtual machine. So it's no longer associated. Now we're going to add a disk. We're going to use existing. We're going to use the butter pool instead of margarine this time. And then we are going to add in the Rhino pool, or this file right here, after it's done copying. We'll hit OK. And again, you can use Vert Manager to do this, but Vert Manager, it's kind of on life support right now. So like if there's bug fixes or security issues with the application, it'll still be supported. But Cockpit is how you're supposed to manage libvirt machines on a single host. And then if you need to orchestrate bigger groups of libvirt machines, there's KubeVirt, which uses the Kubernetes API to manage it. There's Over, but that's kind of going the way of the Dodo. The Red Hat product is being kind of deprecated, or it has an end of life date on it. So people are seeing that as the project dying. There's also OpenStack if you want to build your own private cloud. All right. So we're good here to click add. Now we can run the virtual machine. Boom, it's as if nothing really happened. Because all we did is say, hey, move this over here. Proxmox does have some cool tooling for this, and part of the reason I'm not using Proxmox is their defaults kind of stink. So they use, if we go here and like edit the CP, yeah. So if we go through here, we can see that we're using host pass-through as the CPU. Proxmox is like just now updating the QEMU processor, or the processor a little bit, but when I was using it, it was using a KVM processor, which like doesn't have hardware accelerated instructions, whereas this will say, hey, take the CPU model number from the host and say this is what it's running on. So if we're in Rhino right now, actually we'll SSH in so we can make it bigger. So if we like SSH into Rhino, and then we do cat proc CPU info. We can see it's running 2 Threadripper cores. So that way it gets all of these instructions passed to it. So it can take advantage of things like AES-NI and other hardware accelerated operations, where Proxmox, like, you can get it to do host CPU pass-through. It's just something you have to set. The other thing is it uses block devices instead of QCOW2 files by default, which for backups can be difficult because you have to back up block devices, not files. And if you're backing up files, you can use something like Pango Backup to take an external snapshot of the QCOW2, so you have the operating system and everything as it sits on the hard drive right now, and then all the writes are written to the external snapshot, which is just another QCal file. And then after the backup has been shipped off-site, you can smush them back together. Proxmox, you can do QCal too. I don't know if you can do external snapshots, but you still can do snapshots, so you could still end up with that same feature parity. But yeah, the other reason is I wanted a GUI for OCI compliant containers, so Podman or Docker, and virtual machines in one interface. But if I had like 3 servers, I'd totally be doing Proxmox with an HASF cluster. Okay. That's Rhina done. What else do we got on here? We have my VPN server Ymir. So we are going to go over to Ymir and kind of repeat the same process. Also, we should be receiving alerts from Shiftmon. I am just double checking everything's good with alerts. I actually could go to Uptime Kuma, I guess. Wait, that was down long enough. That should have triggered an alert. Yep. So if we go to Uptime Kuma, we should actually see these services go up and down too. Kind of start teasing the next part of the stream. So everything's up right now. When we take down one of the virtual machines, we'll split off Uptime Kuma over here. We're going to shut down Ymir, which is my VPN server. It is running, what is it? Something.dev. It's not Netbox. What is it? Netbox is a really cool asset manager, or IPAM/asset management tool. Firezone. It's running Firezone. Okay, so now that the virtual machine is off and no longer receiving writes, we are going to move Ymir over to Butter. Also, remember to like and subscribe to the stream if you want to interact with our community more. Feel free to join our Matrix chat. We have links to that down below. So what we should see here in a second is we are going to get an alert from Uptime Kuma. Should see an alert from Uptime Kuma here in a second that's saying it's down. It checks in every minute or so. How's it going, babe? All right. Should eventually send an alert. Or do I have one? Oh god. I need to add a new alert for this. Friendly name. I think I need to add that into like my black box versus white box explainer here in a second. Ymir, Firezone, monitor group. I need to figure out what the heck a monitor group is. That one's not public. So now this will go through the alerts. So it'll add successfully, and then we're going to get an alert saying that Ymir is down when it goes to make that first check. So we'll just wait for that. It's my VPN and all the VPN users are home right now. I'm not super worried. Yep. So it's going to go into a pending state because I had one check fail. Then once another check fails, it will fail completely. So we can eject the CD-ROM because it doesn't need an OS installed on it anymore, and actually remove the device. Now we can remove the device. We're just going to remove this here because it's removed from the pool. I don't want to cause any goofy errors. So we're going to add the disk from butter, and we're going to call it, we're going to add the Mmmm thing. You can add additional options, but usually the defaults are fine for this. I think that was another thing with Proxmox too that stunk, is that it didn't have good caching by default. And I don't know if it's changed in 8, but they were still using the old emulated motherboard. So the defaults are just kind of like old and crusty and just needed updated. There we go. So we get an alert saying that it's down. This alert gets routed to my Matrix room. I don't want to show my Matrix account or my Matrix client on stream, so you'll just have to take my word for it. So now when we fire up the VM, everything should be mounted, copy completed. And notice we're like writing to the pool while it balances. That's something cool about using RAID storage. ZFS does this, LVM does this. While the array is resilvering or rebuilding, you can still use it. So you can operate on the array while it's, you can still do stuff to the array while it's being, while like maintenance operations are happening on it. So also, RAID is not a backup. It is for redundancy. It is not a backup. Kind of the difference between those two is that a good way I like to think about it is what failure you're covering for. So the types of failures that RAID protects you from is hardware failure. So if you lose a disk in a RAID array, it is fine because the array is still up. So you use RAID to protect against downtime, not like human error or like physical or disasters that take away like a whole server. Backups, they cover human error, they cover like physical site issues where like your server goes up in flames, Chuck Norris roundhouse kicks your data center, whatever. So you should have both in most situations for any like sizable deployment. If you're just backing up like your local device, that's fine. Most servers, storage should be cheap enough. If you're in a home lab, I get it. But like most servers, storage is cheap enough that you should have multiple disks. So that way you could actually pop out multiple disks in a pool. To do either upgrades, replacements, stuff like that. As you get into really big storage setups, I set up a Ceph cluster at one of my previous jobs, and it was a 3-node Ceph cluster. So Ceph, along with being able to span multiple disks, Ceph is designed to span multiple servers. So I had bought some disks that I thought were new, but had a few thousand hours on them, and there was performance issues, and I was starting to get like smart alerts from them, and I could actually cover my butt with that. Because I could pull all the drives out of a physical server in the middle of the day, and then pop the new drives in and tell Ceph to rebuild, and there was no disruption to business. I didn't have to work at 2 a.m. And wait for the array to rebuild. So yeah, RAID is not a backup because RAID doesn't fix somebody accidentally deleting a bunch of data or the physical site exploding. It does cover hardware failures in a certain blast radius. Now we should see Mmmm local shiftsystems.net. So the URL is back up. Oh crud, did I tell it to ignore TLS error on website? There we go, now it's okay. I'm guessing it was failing on an SSL issue. So even though I run my own internal CA, getting containers to recognize your own internal CA is kind of a pain in the butt. So there's FireZone. It's happy. Another application is happy. Then that is a black box check. So we're going to go back to here, see what we still have. Okay, so there is one virtual machine that might affect a user, so I need to go talk to that user really quick. So I'm going to be away from the camera really quick. Hey, babe. Am I good to take Home Assistant offline to migrate storage? Cool. Another maintenance pro tip. Always get consent from the business or your users and inform them that things will be going down. You should schedule these in advance, but one, this is a home lab. Two, it's gonna take a few minutes. So this time we should actually be able to get the whole alerting experience over here for black box alerts. So we can go over to Jean. Part of me wants to rename him Jean Valjean because for some reason Les Mis is like a super popular musical. I hated it because there's just bad stuff happening to a French dude over and over again. But the name Jean Valjean sticks in my head. And I think in the show that all my host names are named after, it's Jean, so the French pronunciation, not Jean, which would be the American pronunciation. So we're going to move this over to butter, now that there's no writes happening to it. And then Uptime Kuma should start freaking out momentarily. Again, we do have to wait a minute for this. And then we'll bring over, we can pull this up over the last 24 hours. Because this is going to be our next discussion, which is all of our plugs breaking. Or my smart plug breaking, yep. So there's the alert, we get an alert notification. I actually get host down alerts too, so we can kind of go through that as well. We can actually go through the Uptime Kuma dashboard too in Grafana while that's copying over. Oh, dang, that was fast. Did the resilver finish? Oh, it's still happening. Or the balance. So now we go through here, we remove Jean, we want to remove and delete, or we just want to remove the file. We want to use an existing volume, butter. So something I will say nice about Proxmox is it does automate the process, this process for you. You could say, hey, move this over and delete the old storage when you're done. So you don't have to know like how to use the command line to move QCOW2 files around. But I'm more of an intermediate, or I like to think of myself as an intermediate to advanced user. I'll let you decide whether or not I'm an idiot or not. Alright. So now that's over on butter. You can fire up Jean. I actually do have like a Dell node. I kind of want to fire up and like, I should probably test the Proxmox dashboard to make sure it still works with 8 or if there's been any improvements to their Telegraph integration or not. And maybe do like a shootout between Proxmox and libvirt. Because they're both good tools, they're just good at different things. Because like libvirt's super nice for if you're running Linux as like your daily driver operating system. It's nice to use libvirt instead of VirtualBox. I prefer it anyway. The tooling, you get pretty tools like Cockpit. Or if you just need to like spit out an image with Image Builder, you can do that. Rather than, again, use VBox, which has that like super clunky old interface that sticks out way more rather than like a modern web UI or even Vert Manager. Even though it's starting to look old, it at least uses like the Qt widgets and all that. So, yay. Alright, so all of this appears to be container volumes, so now we can start figuring out how to move our containers over. So we're gonna go, I did not want to kill that. Hopefully that balance just didn't curdle all my data. I hope I just didn't kill my RAID array. So let's go to the virtual machines and... Alright, the cursor's still blinking. Alright, I don't want to go to Armin. All the applications are still loading, so I think I'm good. We'll definitely see later. I also should have screened that. Okay. So, now we need to do container stuff. So, ls mount margarine. So you have image of the hour old, image of the hour, fuzzy images, and all that stuff. So we can... let's actually get a visual on this guy too. So you have these containers right now. So you have some of these containers, namely this one, where we have these volumes on mount margarine over here. So we can move. So cd mount, is it image of the hour? And yes, I did a forbidden chmod on that folder. Mount margarine image of the hour. Okay, so we need to sudo systemctl status zip cat shut down bash. So there's a compose file that cds into that directory and starts up the image of the hour. So if I cat etsy systemd system. Okay, so there's no separate service for that, that's fine. So we can do a sudo podman compose down. Then we should see we lost a container there. Okay. So now what we are going to do, cd .. I'm going to try to put the containers. I didn't like having a separate storage pool, but I guess it'll still show up as a folder. So we are going to cd move mount margarine image of the hour over to mount butter. So vls, the image of the hours over there, and we need to do that with fuzzy images as well. Fuzzy images. So those need the high performant NVMe storage. It's seriously just pictures of my animals. So that rebalance is still working. So now if we go to butter, image of the hour, can edit that startup script to be mount butter. We can get rid of this. So before Podman Compose, before I knew Podman Compose Pull was a thing, I used to use that awful shell command right here to do it. But I know Podman Compose Pull is a thing, and what that will do is it'll read through all the images in a Podman Compose image. So if I do Podman Compose Pull, it will check to see that all the images are there. I also forget if Zeke has internet right now, because for some reason, like, all the networking to it works, but it can't, like, ping anything. So we'll just kill that for now. Sudo podman compose. Actually, we might need to go into the other compose file and do the same thing. But let's go to mount margarine. See if, yeah, networking has been super weird on Zeek. Like sometimes when it boots, it'll just not have internet. But it looks like everything is working. Yeah, figure that out off stream, because there's a good chance I mess up my internet when I do that. So cd mount, I guess I can just do sudo nvim mount, or I don't want to be in that folder, mount margarine jellyfin, sudo nvim docker compose. Okay. So we want to find margarine, change it to butter, margarine, butter. Yeah. That's the other thing. I have to be like careful when I break the internet. So if it's like hobbling along, I have to like wait for my wife to take a nap, or she usually goes to bed a little before me. So I'm safe there. Okay. So that needs to get edited. The other thing that we will need to do, sudo nvim start. Wait, what the heck? I could have swore there's the cat etsy systemd system. Okay, so that runs inside of the other script first. So let's edit this. Sudo nvim. This is making me want to switch to Docker Compose because I don't have to do this with Docker, and I run it as root anyway. Podman is in Docker, kind of like libvirt and Proxmox. There's great reasons to use both of them. Sometimes you don't necessarily need all of the like super easy to run as rootless, and some of the other nice things that Podman does provide, where it's like super easy to run containers is not root. There are other use cases where having the Docker socket work all the time, like Woodpecker CI is nice, or like not having to write your own custom startup scripts to get a like container to start at boot. So yeah, no solutions, only trade-offs. Okay, so now we need to do a sudo. Let's just edit that Docker compose file one more time. So there's no volumes we need to worry about passing here. We can do a compose down. I don't think we have no instances of the word margarine here, so that's good. So we can do sudo podman -compose down. We'll see all those containers disappear. Cool. So now we need to go up here, ls. So we are going to sudo move mount margarine jellyfin over to mount butter. This one's going to take a minute because there's like a few hundred gigs in my jellyfin folder. Oh, I'm still on Zoe on that one. That was not scary at all. So jellyfin's there. Again, we just gotta wait for a few hundred gigs. So while all that stuff's going on, we are going to discuss some black box versus white box monitoring. So we're going to use something that isn't like Linux nerd stuff to explain this, because sometimes I think that could be super helpful. There's more to life than just being a Linux nerd, believe it or not. Okay, so Uptime Kuma's mad about Sasha and Orwell being down. We can live. I can live with that. Pretty sure it was communicated with the wife that some services were going to go down during the stream, but not the internet. So another thing to do is to scope outages, both in time and like blast radius, so the number of things that could possibly be affected and the things that are likely to be affected. So we're going to go over the different types of alerts, or go over a couple of different monitoring methodologies. In my house, I have upstairs plug 2. So I live in Iowa. Sometimes the air hurts my face because it's really cold out. Sometimes the air sunburns my face and it's 100 degrees out. So heating and cooling is super fun in the Midwest, especially when you live in like an old house. So you can hear behind me that I have a standing AC unit, and it uses a lot of power. It uses about 850 watts of power regularly, which is a bit of a problem when you like to have a lot of electronics, or you need to run like an air filter or something else, and you only have a 15 amp circuit. A 15 amp circuit should be able to handle somewhere on the air, or somewhere around like 1400 watts before it'll flip. So if there's any big spikes or anything like that, you have a power outage, or the breaker will flip, and then the AC stops working. Then it gets really sweaty up here, or I want to go upstairs and work, but I can't because it is just sticky up here. We've been having some like high 90s days with high humidity, and it's just not fun to be up here. So what I did, I put the window AC unit on a smart plug, double check that it can handle like 800 or 900 watts of power going through it, and now I can get metrics on it. The other thing I did was set up an alert. Is that copy going? Still going. So now I get alerts when that smart plug goes down, or upstairs plug 2. It's just a simple ping check. I can monitor the response time, And this is also in my Grafana setup. Besides in Home Assistant, dashboards, Uptime Kuma. So I can go to upstairs plug 2. I can monitor the ping, get the response in both Grafana and Uptime metrics. Can also get an alert when data is not being sent. So the Uptime Kuma approach is a black box approach. So Uptime Kuma doesn't have any inside knowledge to what's going on. It doesn't have any inside knowledge of what's going on because it doesn't have an agent. It doesn't have any sort of like deep knowledge of what's going on with the system. So it's as far as the monitoring agent is concerned, it doesn't know anything that anyone else doesn't know. And that's kind of the difference between black box and white box. White box monitoring would be something like Home Assistant, the Home Assistant integration. So Home Assistant can get metrics and get more advanced knowledge through MQTT. It's a bit more setup because you have to have Home Assistant and the MQTT broker set up, but you get not only how long it's taking the application to respond, but you get more deep, in-depth metrics because it has deeper knowledge of what's going on. And kind of the reason you would want to use like a white box approach is you can drill into like exactly how much power it's using in this case. Whereas with the black box approach, I just see how long it's taking for it to respond. And so when things go bad, I can see that, yes, it's broken, but I don't get any insight into why. So if I go into a longer time period, I can see that there's like some initial power spikes when it turns on, but there's no other context as far as like what's happening with the amount of power it's using. Like there's nothing else that could be causing it that we're monitoring right now. So I get a better I not only get the notification that something could be wrong, I get what is happening beforehand. Whereas the simple ping check, I just see that the plug went offline. I don't get to see how much power it was using in this case. But one upside of using black box monitoring is that you can actually see things the way your customers would. And if you're using like load balance systems, you kind of have that rate effect where one origin in the load balance pool could be down, but it not impact your customers. So as an operator, you might care that you have a down node, but as far as like your SLA is concerned, the customer can still get to the application. So it's good to have both types of monitoring. Because if you have a down origin, you don't want to calculate based on like any individual origin being down, because that's going to tank your uptime. Because you could take nodes out of maintenance pool, or you could put like an individual node in maintenance for an upgrade, put it back in. And there's all sorts of reasons why an individual node would be down, but your application could be up. So black box monitoring is good for painting like the picture of what are your customers seeing. So like just seeing that I get this response when I hit this URL, or I get this text from an API when I curl it. So, but you don't get those rich metrics because you don't expose those to your customers, and it's hard for like an HTTP URL to get every metric about it, or a publicly accessible like HTTP request to show every little thing going on inside your server you would if you had like the MQTT integration set up with Home Assistant, or the MQTT integration set up with Home Assistant, or having Telegraph installed on a box. So we can do, so just for an example, let's just do We'll search for entity ID. So if I just do a query for entity ID, this is a big chunky query. I forgot to time bound it. So I get all 40 metrics. I can see watts, kilowatts, hours over time. I get all this information because I took the time to do the more complicated setup and can see everything going on. Whereas with the uptime Kuma approach, all I really get is like, it took this long to respond. So I get much richer data from that. So it's definitely worth it to, usually it's definitely worth it. The upside of setting up uptime Kuma, I can do it on my phone at 2 a.m. when I found out that the breaker went off. Whereas like setting it up with Home Assistant is a bit more involved. So again, no solutions, only trade-offs, and obviously having both is good too. So now how do we get a Grafana alert that notifies us that this is down? We are going to use the lag query, which is a really cool operation, or a really cool function that you can use for alerting. What the lag function does is calculate the number of seconds since something bad has happened. Oh, yeah, high IO weight. That's good to know. So Armin's having a time with IO weight, shockingly enough. And I am getting an alert for that right now. So host down is a good example of this. And we can copy it, and we are going to do smart plug down is above 200 for 1 minute. Yay. So what the lag operation does, run queries. So we can see that Ymir was down for so long, and I got an alert that it wasn't sending data. So instead of using the CPU usage idle metric, we can use that, I think it was like VA value or something like that. Underscore value. And start range step 1000. Yikes. That's not good. We are having IO weight issues on here, aren't we? We're resilvering the array, so it's churning through a bunch of disk IO right now. Let's try this again. Copy. Home Assistant. Edit. Okay. Let's do this. Let's do this. There we go. All right. So we want to do, that's 5 minutes. So if we want to narrow this down to just have the upstairs plug. Oh, some of these have like way longer wait times. So I think what's happening here is like the sample rates every 300 seconds. So in this case, it might actually be better to do the consistent ping. And another, I guess, difference between black box and white box monitoring is sometimes you can't control how fast your application sends data. So in this case, we're using the Home Assistant integration. We're using the Home Assistant integration, and we can't really control the interval at which it sends data. NTOP-NG is another good example where it would be nice, especially if I was using Grafana Cloud, where you get billed for the number of time series you send, not only total, but if you send it more than once a minute, you get billed multiple series. To be able to control that, sometimes that's out of your hands. In this case, it might be, it might not be, but the Tasmota plugs are sending data at a much longer clip. So because I want a faster alert time on it, this isn't the case. Again, we can say we would do entity ID is dead, entity ID is down, click save, and we would have that managed alert. But sadly, we don't get that luxury today. But I do believe host down. We can still get rid of it by changing. Let's do a get pull. How long have I been streaming? Oh. Get pull. Okay, so we do have a get pull. That's done. So let's change this host down alert really quick. And then I think I'll cut it there. It's been a good stream. Everything's gone pretty smooth. I'll update the shift systems matrix. I'll update the matrix chat about how that resilver ended up going. And also, I tend to, like, if there's something unresolved on the stream, like I have to go do something else or I just need to go step away and clear my head, I'll usually update that, hey, I was able to get, like, paperless NG working, or something like that in the shift systems room afterward. So that host down query, we are going to change it to match this one. I've been happy with using the lag operation for here, so we'll go to edit. I'll just copy this guy out, plop it in here, save. Alerting docs. Changed host down query. And then we'll do a push. You have to do a get push. Awesome. So that's all I had for today. I had a really good time streaming with you guys, and I will chat with you guys later. Remember to like and subscribe, join our matrix room, and if you have any automation consulting questions, email sales@shiftsystems.net.